Hey! Hey! I'm Mr. O, here with another moment at the Children's Museum of Houston. In some prior Oh Wow moments, we've discussed electric motors and how they work. For example, in Get Your Motor Running and Motor Sculptures. You can view both those videos along with many others at mycmh.cmhouston.org. Today, however, we're going to talk about a different use for electric motors. One that's been disrupting our lives and my videos for far too long. The off-balance or vibrating motor. Off-balance or vibrating motors are normal electric motors with one addition, a weight on the rotor that is off-center. When the motor is turned on, that weight causes the motor to shake or vibrate. So why does having an off-center weight cause vibrations? Well, remember from prior Oh Wow moments, Newton's first law of motion states, in part, objects in motion tend to stay in motion. When we're talking about motion in Newton's laws, we're talking about straight line motion, like when I push this ball and it rolls in a straight line. Its inertia will keep it moving in a straight line until friction, an outside force, makes it stop. In the case of this motor, the weight isn't moving in a straight line, it's spinning. That means its inertia keeps changing. And because the weight is off-center, that means the entire system is off balance. Imagine we've frozen one instant in time of the weight spinning on the motor. Right now, the weight wants to continue in a straight line motion. This pulls on the motor, making it move just a bit in this direction. This pulling of the motor off the center causes the motor to move slightly. And because the weight keeps spinning around, it keeps changing the direction of that motion. That causes the entire motor to vibrate, which allows us to invent a lot of things. Like cell phone vibrations, and some fun toys you can make at home. Time to shake things up. Inventing is fun, but it can also be dangerous, so always have a responsible adult helping you. We're in the David and Jean Wiley Foundation Invention Convention exhibit to make ShakeBots, fun toys that move around thanks to off-balance motors. Now, normally this is where I tell you what materials to go get. However, in this case, ShakeBots are a very open-ended activity. That means they can be made with a lot of different materials. So instead, I'm going to go over the two major components, the off-balance motor and the base. That information will allow you to go invent your own ShakeBots. There are several different kinds of off-balance motors, most of which you can order on the internet. I recommend getting motors in the 1.5 to 3 volt DC range, which is what most batteries can easily power. This one is a larger one, relatively speaking, good for a heavier ShakeBot. These smaller ones, which are in some cell phones, and these pancake motors are good for lighter ShakeBots. But what if you have a normal electric motor like this one? Well, all you need to do is add an off-balance weight. A very easy weight to use is a piece of hot glue stick. Just cut off a piece and push it onto the shaft, making sure to not center it up. So you also need to plan for a battery to run your motor. Now, the key behind this is weight. The heavier your ShakeBot is, the more vibrations it's going to take in order to get it to move. So, lighter weight batteries tend to work better with smaller motors. For smaller motors like these, I like to use CR2032 batteries. Just tape one wire to the top and the other to the bottom to complete a circuit. For larger motors, a AA or AAA battery works well. Just tape one wire to either end to complete the circuit. You can wire in a switch if you want, but I prefer to use tape on the battery. I always keep one wire taped to one end of the battery. Then, when I'm ready to turn it on, I tape the other end to the other end of the battery. When I'm ready to turn it off, I just remove that tape. Now, let's talk about the second part. The base is whatever you tape your motor, battery, and whatever decorations you want to build your ShakeBot. So it can be a variety of different things. A plastic cup, a paper tray, a fingernail brush, or even a cardboard box would all work well so long as you can attach a battery, motor, and decorations to it. There are three key factors to keep in mind as you build your ShakeBot. First is one I've already mentioned, weight. The heavier your ShakeBot, the more vibration it will take to move it, so consider using a larger motor for bigger projects. Before you place your motor, make sure the base doesn't interfere with the spinning of the motor. If the motor can't spin, there won't be vibrations. When attaching the motor, make sure it is secure. A loose motor means lost vibrations and reduced motion. Tape can work, and some motors, like this pancake motor, may have a sticky side, but I like to use hot glue to make sure it stays put. Remember to have an adult help you with the hot glue gun so you don't burn yourself. One final tip. Whenever you put on the battery, use tape. Eventually, you will need to change out your battery, and using tape makes that change out pretty easy. With all of that in mind, you're ready to make your own ShakeBots. Here are just a few examples, but how you decide to build and decorate them is up to you. No matter what you make, we'd like to see it. Please share it with us on the Children's Museum Houston's Facebook and Instagram pages. Plus, make sure to subscribe to all of our videos on YouTube. And if you have a question or an idea for a future Oh Wow moment, you can email me at Mr. O, that's MRO@cmhouston.org. I hope you have a lot more fun making your ShakeBot with vibrating motors than I've had with a certain other vibrating motor. This has been another Oh Wow moment from Children's Museum Houston. We hope your mind can come out to play.